इसमें सबसे फर्स्ट टॉपिक मैं आपके साथ जो शेयर करने जा रही हूं कि किसी प्लेन का ओरिजिन से डिस्टेंस निकालना हो, यानी डिस्टेंस ऑफ अ प्लेन फ्रॉम ओरिजिन हम किस तरीके से निकालेंगे। हमें पता है कि ओरिजिन होता है पॉइंट 0, 0। तो मान लीजिए मेरी इक्वेशन ऑफ प्लेन दी हुई है 3x plus 4y plus 12z is equal to 5, and we have to find the distance of the plane from the origin. तो इसका फॉर्मूला होता है ओरिजिन से निकालने के लिए, दिस इज d, that is mod of d under root a square plus b square plus c square, all the coefficients x, y and z. So very simple. So what is the value of d over here? Mod of 5 under root 3 square plus 4 square plus 12 square. When we solve, we get 5 over 3 3s are 9, 4 4s are 16, then 144, and when we sum up, we get 5 over under root 169, which is equals to 5 over 13. So in this way, we can find the distance of a plane from the origin. अब इसी में next step we have to find a distance between the point in a space and the plane. For example, the equation of plane is given as 3x minus 4y plus 12z is equal to 3, and the point is 6, 5, minus 2, from where we have to find the distance. So for that, formula is ax1 by1 cz1 plus d. We have to take the absolute value over under root a square plus b square plus c square. Now this is the equation of the plane, where that means format is equation of the plane is ax plus by plus cz plus d is equal to 0, and the point is in the format x1, y1, z1. That means we put different points x1, y1, z1 in place of x, y and z. So according to this, we proceed in this way. We have the equation of the plane 3x minus 4y plus 12z is equal to 3. So equation of plane is reduced in this form: 3x minus 4y plus 12z minus 3 is equal to 0. Make the equation of plane in this form and then substitute the value of the points in place of x, y and z. So distance between plane and the point is mod of 3 into 6 minus 4 into 5 plus 12 into minus 2 and minus 3 under root coefficient of x, that is 3 square, coefficient of y minus 4 square, and coefficient of z, that is 12 square. So ultimately what we get, 18 minus 20 minus 24 minus 3 over 3 3s are 9, 16 and 144. Now when we solve, we have to add up all of them, that is 27, that is 47, 47 minus 18, 47 minus 18, 29, that is minus 29 over under root 169, that is 29 over 13. So this is the distance between plane and the point which is given. So this formula is used when you have to find the distance between the plane and the point. In the Cartesian form and in the vector form, when the 3 points are given to us. Now, firstly, what is the equation of plane in the Cartesian form? For example, 3 points which are given as x1, y1, z1, x2, y2, z2 and x3, y3 and z3. These 3 points are given to us and we have to find the equation of plane. The equation of plane is in this form: x minus x1, y minus y1, z minus z1, then x2 minus x1, similarly y2 minus y1, z2 minus z1 and x3 minus x1, similarly y3 minus y1 and z3 minus z1. This is the equation of the plane in the Cartesian form. When you derive the equation of plane in the Cartesian form, then you have to convert this equation in the vector form. I will tell you one by one by taking an example, and then I also convert this equation of Cartesian form then to vector form. Now, for example, the 3 points which are given to us are, and we have to find the equation is, for example, we have 3 points, 3 comma minus 1 comma 2, and the next 3 points which are given to us 5, 2 and 4, and next 3 points they are minus 1 and 6, and we have to find the equation of the plane. Now this is x1, y1, z1, this is x2, y2, z2 and similarly. So in place of x1 what we write? 3. In place of y1 we write minus 1. Then in place of z1 we write 2. Okay. Now x2 minus x1, this is x2, that is 5 minus 3. 5 minus 3. Now here we get y2, that is 2 minus 1. Similarly 4 minus 2. Now x3, what is the value of x3? The value of x3 is what? Minus 1. Minus 1 minus 3. Similarly for y3, for y3 we have minus 1, y1 that is minus 1. Now z3 we have 6 and z1 we have minus 2. If we watch carefully, we can observe that all the minus 3 are there, all the minus 1 same. Okay, when you practice you can do it easily. Now this remains as it becomes y plus 1, and here 5 minus 3, when we solve, what does it become? It becomes 2. Here it becomes 2 plus 1, that is 3. Here it becomes 2. And now here it becomes minus 4. Now plus minus 1, that is 0. And it becomes 4. Okay. So in this way we got a determinant type of. Now when we solve we get x minus 3. Now 3 4s are 12 minus 0. Then we put a minus sign over here. Then y plus 1 and 2 4s are 8 minus 2 4s are 8. Then z minus 2 and 2 into 0, that is 0, plus 4 3s are 12. Now we solve this equation, we get 12 x minus 3 minus 8 and 8 16, y plus 1, similarly 12 z minus 2 is equal to 0. Now we solve this equation and ultimately we get the equation of the plane for these 3 points. Now see how we solve that. We multiply it, we get 12x minus 36, then minus 16y minus 16, then plus 12z minus 24, which is equal to 0. This is the Cartesian form of the equation of the plane. Now 12x minus 16y plus 12z minus 36 minus 16 minus 24 is equal to 0. When we add, what we get? 6, 4, 10, 16, 3, 1, 4, 1, 5, 2, 7, 76. That is 12x minus 16y plus 12z minus 76 is equal to 0. We divide it by 4. 4 3s are 12, 4 4s are 16, 4 3s are 12, 4 1s are 4, 4 9s are 36. So this is ultimately the equation of the plane is equal to r dot n is equal to t. So we just write simply r dot, in place of x, y, z we write I, j and k. X for I, y for j and z for k. That is 3i minus 4j plus 3k, and this 90 d vector we write over here 90. So this is the vector form of vector equation of the plane. Clear? So